The diagram below shows a piece of land. The measurements are shown in meters. So from here to here is 60 meters, from here to here is 68 meters, from here to here is 65 meters, 58 meters, 52 meters, 28 meters, and 0. At equal intervals of h, so equal intervals of h, equal distance apart, along AB, this is AB, perpendicular measurements are taken to the boundary as shown. So here are our perpendicular measurements. If the trapezoidal rule gives the area of the piece of land as 4,515 meters squared, find the value of h. So we need to find what the distance is between. So the first value of y is 60. And the last y value is 0. And the other y values can be seen from the diagram: 68, 65, 58, 52, and 28. So we're going to use the trapezoidal rule, which is given to us in the formula book, but it is better to just learn off a method more so than to use the formula. So it's always going to be h over 2 multiplied by the first plus the last plus 2 times the sum of the other y values. So these are our y values. So we know that the area of the piece of land is 4,515 meters squared. So we've got 4,515 is equal to h over 2 multiplied by the first, which is 60, plus the last, which is 0, plus 2 times the rest. So it's going to be 2 times 68 plus 65 plus 58 plus 52 plus 28. So 2 times 68 plus 65 plus 58 plus 52 plus 28. So 60 plus 0 is 60. And 68 plus 65 plus 58 plus 52 plus 28 is 271. We've still got the 2 in front. And 4,515 multiplied by 2 is going to be 9,030. So we're multiplying by 2 to get rid of the fraction part there. So we have 9,030 is equal to h times 60 plus 2 times 271. And 2 times 271 plus 60 is going to be 602, and that's all stuck onto the h. And then dividing across by what's stuck onto the h, we have 9,030 divided by 602 is 15. So h is 15. So the distance of each of our intervals is going to be 15 meters. The trapezoidal rule can also be used to approximate the areas in the xy plane. So this is our x-axis, this is our y-axis, this is our xy plane. This may involve using the equation of the curve to evaluate y values. To do this, we simply substitute the x values into the equation of the curve. So the diagram shows the curve y equals x squared plus x plus 1 in the domain x values greater or equal to 0, less than or equal to 4. So here's our curve. Y equals x squared plus x plus 1. Part 1, copy the following table, then complete it using the equation of the curve, so basically fill in the y values. Part 2, hence use the trapezoidal rule to estimate the area between the curve and the x-axis. So this area. So substituting 0 into our equation in place of the x, we have 0 squared plus 0 plus 1. So we just end up with 1 for our y value, so we get 0, 1. Subbing in 1, we end up with a y value of 3. Subbing in an x value of 2, we get a y value of 7. Subbing in an x value of 3, we get a y value of 13. And subbing in an x value of 4, we get a y value of 21. So our points along our curve are going to be 1, 3, 7, 13, and 21. Part 2, hence use the trapezoidal rule to estimate the area between the curve and the x-axis. So the area between the curve and the x-axis. So we need to find this area. Hence means using what we've already found. So we found that these y values are 1, 3, 7, 13, and 21. So these are our heights. So remember, our trapezoidal rule is the area equals h over 2 multiplied by the first plus the last times 2 times the others. So for the trapezoidal rule, h is equal to 1. So the distance of 1, equal intervals of 1, so it's 1 over 2. Then the first is going to be 1, plus the last is going to be 21, plus 2 times the others, so plus 2 times 3 plus 7 plus 13. So 2 times 3 plus 7 plus 13. 1 plus 21 is 22. 3 plus 7 plus 13 is 23, so it's 2 times 23. 2 times 23 plus 22 is 68, and half of 68 is 34. So the area between the curve and the x-axis we estimate to be 34 units squared.